All right. Back to business here. All right, so same problem. We have our tertiary alkyl halide, and water is a weak base, weak nucleophile. So again, we're going to be doing, according to our chart, an SN1 and an elimination product. But again, for SN1, we got to draw both our possible stereochemistries. All right, and so even though I'm reacting this with water, when I'm doing my substitution, what am I actually attaching to that electrophilic carbon? What's my new functional group going to be? OH. Just OH, right? It loses a hydrogen for those neutral nucleophiles. All right, so what I'm going to do, and this is always sort of a good idea, is to sort of start with what you're given here. Obviously, it's much easier on like a tablet or something like that than it would be on pencil and paper. But in general, I'm always going to sort of just recreate all the amount of carbons that I had on that left-hand side. Okay? I will say, just in terms of studying, one of my favorite places to study as a student was an empty classroom, because then you can utilize the whiteboard. And it's just perfect for this sort of thing where you can easily kind of erase and stuff like that. Like obviously tablets are great, but we don't all have them, right? Anyways, yeah, so like a whiteboard or something like that is a great place to practice chemistry, especially organic chemistry and drawing structures. So I'm going to draw one product where I don't touch any sort of dashes or wedges. All I do is replace my leaving group with my new functional group there. All right, and then I'm going to draw another one. But this time I'm going to convert, I'm going to again sort of swap out my leaving group and my new functional group. But now I'm going to switch my wedge to a dash. And my dash becomes a wedge. All right, so again, because this is SN1, we need to draw both products. So these are my two substitution products. Now I got one more for my elimination product. This carbon right here, it's got to be involved in that double bond, right? Because it's the one at the base of that leaving group. So then the question is, which one of the three carbons that are attached? Because I got three options here. I can either form a double bond with this carbon, this carbon, or this carbon. 1, 2, 3. All right, so just for the sake of completeness, I'm going to draw out each of these products. If it formed that double bond with carbon 1, that would be this. And I can always double check my structure how? Counting carbons, right? It's going to look a little bit different, so I'm just going to 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, okay? Always a good idea to count carbons. If you left this as a wedge, I wouldn't be too picky about it, all right? But technically speaking, it's not correct because the geometry of a double bond, remember we talked about how all these atoms are actually in the same plane. So they form like this flat shape around our double bond. But I'm not going to get too bogged down about that, okay? Or I can form it on the other side, right? So if we just kind of want to visualize, I have this bond here. This is where my chlorine used to be. Actually, let me, right? And I'm going to pick it up, and I'm either going to form a double bond on this side, I'm going to move it around, form a double bond on this side, or over here. Those are my three options, right? But it's got to be based at this carbon here. So again, my one product is there. I also have this one, And then lastly, that one there. All right, so A, B, or C, which one is going to be my elimination product here? A. And why A? Because it's got that more highly substituted, right? This is a, has 4 neighbors, 1, 2, 3, 4. This one's pretty highly substituted as well, but it only has 3, 1, 2, 3. And this one only has 1, 2. So yes, A is going to be my major product. So when I'm drawing my products of this reaction, let me just get rid of all these markings. I'm going to have my 2 substitution products as well as my major elimination product here. So all 3 of these we would expect in our mixture if we reacted our tertiary alkyl halide with a weak nucleophile, weak base. All right. So again, here's our little chart here. I'm going to do one from this category here so we can take a look at what the structure of this thing looks like. Let's do... All right, and so this is this CH3, 3CO minus. All right, and I'm going to draw out like the stick structure of this, and I just want us to be able to convince ourselves that what I'm drawing is indeed this formula here. All right, so first things first, if you're given this structure here, this bond line structure, let's make sure that we can spy that it's really this formula on our chart here, okay? So what this formula is telling me in this condensed sort of way is that I have these 3 methyl groups, 1, 2, 3, attached to this central carbon. And that has this oxygen with a negative charge, right? So can we see how our bond line structure matches that condensed formula there? Okay. All right. So again, this is our strong base, weak nucleophile here. Because it's a good base, but a crappy nucleophile across the board will prefer elimination reactions. All right, so everybody take a second and give me my elimination product. So elimination product, right? So again, I'm going to take this bond right here, and I'm going to either form a double bond on this side or a double bond on this side, right? In this case, in all cases, I'm going to go with the more substituted carbon All right, and again, we called this a weak, nope, a strong base, weak nucleophile. All right, so now we're going to take this same substrate and we're going to take a very, very similar reagent. All right, I'm just going to sort of remove two of those methyl groups. I still have that same oxygen with the negative charge, which is really the atom that's playing the role of the base, that's doing the accepting of that proton there. But let's see if we can't figure out what category this thing falls into here using our chart. So if I go to my chart here, again, this was my structure. Everybody take a second and see if you can't find which category that substrate or that reagent would fall into.
Strong base, strong nucleophile?
Strong base, strong nucleophile. So, first of all, this thing here, the ETOH stands for ethyl, but really, again, we also have, it can be any length. It doesn't just have to be an ethyl group. Okay? So, this top one was a strong base, but a weak nucleophile. And down here, this is a strong base, but also a strong nucleophile. All right, so first of all, just to kind of finish off this reaction here, if it's a strong base, strong nucleophile, and I start out with this secondary alkyl halide, what's my major product going to be? It's still going to be this elimination product, all right? So in this particular case, there wouldn't be a difference in terms of my products, right? If we look, both of these categories are elimination for secondary, okay? So my product's no different. But let's focus on these nucleophiles real quick and try to see if we can't reason why one would be strong and one would be weak, okay? They're both good bases, right? They both have that oxygen with the negative charge, which just like a hydroxide ion is a good base. But why is this one a crap nucleophile and this one is a good nucleophile? All right, like if I took this and instead of having a secondary alkyl halide, if I switched this and we had a primary alkyl halide, I would get two completely different products, right? In the one, I would get my elimination product, but in the other, I would actually get a substitution product. All right? So again, why do we think that this one is a bad nucleophile compared to this one? What's the big difference between those two reagents?
More carbons?
More carbons, it's crowded, exactly, right? So this is this big, bulky, what we would call a bulky base. It's just too big to get in there and react with that electrophilic carbon. It itself is just like crowded as all get out. And remember, in order to be a nucleophile, in order to have these substitution reactions, it has to be able to get at that carbon right there, the carbon at the base of the halogen, what we call the electrophile. So if this thing is big and bulky, it's just really hard for it to get in there, okay? Compared to something that's nice and petite and can get in there very easily. So sort of the same argument we made to distinguish between these two here was because this carbon's more crowded for secondary and tertiary, right? So it prefers those eliminations. Same thing if that substrate or that reagent itself is big and bulky and crowded, right? In the case of our strong base, strong weak nucleophiles, these are these big, ugly, crowded things here, okay? This thing, you can just kind of make a note, is what's called tert butoxide is the name of this. The only reason I bring that up is because quite often it's also abbreviated as TBUO-, tert butoxide. All right, so for our remaining time here, what I'm going to do is just put down a bunch of examples, and I want you all to do it from scratch here using our chart. So if you, I don't know, to make everybody's life easier, like take a picture or something like that so we can have this in front of us. If you don't have this particular slide already downloaded, but we want to have this list here. All right. All right, so what I'm gonna do is kind of just quietly fill in the answers up here so you can double check if you get stuck. But again, the goal is to be able to do it on your own, right? So try to use that chart to figure it out, but I will kind of quietly fill in answers up here. Oh, crap. Oh, well. All right, so those first two were both tertiary alkyl halides reacting with a strong nucleophile but a weak base. And so I would have SN1 for both of those, and so I'd have to draw my two substitution products. The first one's a little bit easier to see what's being attached to your molecule here. We start out with this neutral SH2. So we lose a hydrogen and it's the sulfur. This thing is a little bit bigger and uglier, so it might make it a little bit more intimidating. But again, when I see sodium, I'm gonna erase it and put a negative charge. And it's that negatively charged oxygen that is going to be attached to my electrophile. All right, this next one is a primary alkyl halide, but now I have that big, bulky, strong base, weak nucleophile, which means that I'm going to get my elimination product, my 4-carbon alkene. Okay, and then for this last one, this is that special category. It looks like it's a secondary alkyl halide, but because it's located right next door to that benzene ring, we put it into its own category, the benzylic alkyl halide. So this is kind of falls in the same category as the tertiary. This is a strong base and a strong nucleophile. All right. The one thing that we got to be careful about with these ones, so first of all, according to my chart, what is my reaction going to be? Substitution or elimination? Elimination, okay? The one thing that we got to be careful about with these in particular is, again, here's my bond, right? And I'm going to pick this up and I'm going to make a double bond. So, oh, bummer. It's either going to be moving over here or over here, okay? Again, we want to form the more highly substituted alkenes, so it's really tempting to go this way. But what's the problem with that molecule? It's illegal, exactly. That carbon's got too many freaking bonds going on, right? So in this case, the only option is to put your double bond on the other side, okay? So I do get my elimination product, but importantly, it's got to form over here because that's really the only place that I can put it. Oh my gosh, stop snapping in place. Cool. All right, so based on sort of what we did today, again, at the beginning we did some examples where I was like, look, give me the substitution product or give me the elimination product. And so you want to be able to do that, okay? As well as if I just give you a substrate and a reagent, we need to be able to use this chart here. Again, what you're going to be given on an exam, the very first question, or at least the first question from this section, is going to be a blank chart like this, and you got to fill it in. All right, that's going to be the first thing, because then you're going to have to know how to use it. But I will give you this part up top. You don't have to memorize what reagent falls into which category. You do need to be able to fill in this bottom part here. All right? Cool. Say it again. Yeah, 2 weeks. That sounds right. Yeah.